Number 29, the x and y components of a particle's acceleration is given as a function of time r, and they give you the acceleration in the x and y direction. What's the magnitude of the particle's velocity at t equals 1 second if its initial velocity is 0? All right, so we need to get we need to integrate the acceleration in the x direction to get velocity in the x direction. At time equals 1 second. So to integrate that, we have to increase the exponent and divide the coefficient by the new exponent, so -4 divided by 2. All right. And then increase the exponent and divide the coefficient by the new exponent. So now what we need to do is plug in t equals 1 in for t, and we're going to get -2 plus 1, so v in the x direction is -1. Right? Now the velocity in the y direction at t equals 1, we need to get the integral of 2t, so this goes to t squared, and the 2 gets divided by the new exponent, so it's just t squared, plus t, and the 3 gets divided by 1, so it's 3t. Let's plug in, so that's -4 plus 3. Whoa. Let's roll that back a little bit. 1 squared is 1. T squared. Yeah, 1 squared is 1 plus 3. Yeah, so Vy is equal to 4. Yeah, that makes sense. So we have a vector that's going -1 this direction. Let's move that over a little bit. It's moving -1 this direction, the x direction. It's moving +4 that way. So we have a vector of velocity that's going that way. So to get the velocity at time equal to 1 second, we need to get the square root of 4 squared plus -1 squared. Square root of 16 plus 1. Velocity is going to equal the square root of 17, which equals 4.1 meters per second.